Hi, my name is Daniel Brinkman. I'm a computer science and cybersecurity student at the University of Nebraska at Omaha.
Hello, my name is Travis Munyer, and I am a computer science and mathematics major here at the University of Nebraska, Omaha. And today we have for you a presentation on the integrative use of computer vision and unmanned aircraft technologies in public inspection. Our paper discusses various applications of computer vision enhanced unmanned aircraft systems to public services. Unmanned aircraft systems are commonly referred to as drones and are any aircraft that do not contain an onboard pilot. Computer vision is a scientific field studying high-level understanding from digital images or videos. Our paper briefly discusses various methods of applying computer vision enhanced unmanned aircraft systems to bridge inspection, traffic monitoring, and urban planning, but the main focus of this paper is a case study of computer vision enhanced unmanned aircraft system-based fraud detection. According to the Federal Aviation Administration, fraud is defined as any object, live or not, located in an inappropriate location in the airport environment that has the capacity to injure airport or air carrier personnel and damage aircraft. The dangers of insufficient fraud detection can lead to expensive damages, and in extreme cases can lead to the death and injury of various personnel or guests in the airport. The main research problem that our paper solves is the lack of a sufficient publicly accessible dataset of foreign object debris. Now, a baseline dataset allows for various researchers to compare the results of their algorithmic experiments. In order to create this dataset, data was originally collected in the video format at a local airport, specifically the Millard Airport in Omaha, Nebraska, using unmanned aircraft system-mounted cameras and portable cameras. These videos were then split into individual frames using the properties of videos. And this property that I'm referencing is the fact that videos are essentially a combination of several frames or images. And we created a tool that would split these videos into their individual frames and save these files for us. This tool actually allows our dataset to be easily extensible for future cases, due to its precise and repetitive nature. Individual frames were then annotated using the computer vision annotation tool, or CVAT. We then tested the dataset to demonstrate its practicality on the You Only Look Once algorithm, the famous YOLO algorithm. And of course, since our dataset is publicly available, the dataset will be available for download at the link at the bottom of the slide. Our dataset contained various categories, and the number of instances of each category is contained on this slide.
So from the previous table, the images were split at random, with 75% going into training and 25% going into testing. These splits were done within each object classification just to ensure that nothing was excluded from the testing. And each image was trimmed to a 400 by 400 resolution to decrease the time of the training. After the experimental analysis, a 95.2% precision, a 99.3% recall, and a 99.1% mean average precision were recorded. You can see that we have some examples of the model after training in detection on the right. The resultant model was able to detect even very small objects, such as a nail that exists in the top left image. And that decreased resolution did not seem to negatively impact the way that the model handled any object classification or detection. Some of our paper contributions include that we introduced a new concept for fraud detection using computer vision and UAS techniques. We proposed a theoretical framework for future automated fraud management. This is discussed further in our paper, as well as the extensibility from fraud to other applications. And lastly, we initialized a new data set of various objects that commonly become fraud in airports. Some of the future work that can improve automated public services include the exploration of automated removal of fraud, the development of automated navigation of UAS, and fraud detection algorithm enhancement. These are the references that were used in our slides, and that will conclude our presentation for this morning.